Hello and welcome back. We're going to work on some more related rates problems. These problems could be referred to as Pythagorean problems. So just right up here, I'm going to write x squared plus y squared equals r squared. We'll see why. Okay. First one here reminds me of a story of my father who, as a retired person, was climbing a ladder and it slipped out from under him. It's a terrible story. When we're in class sometime, I'll tell you about it. So here we have a wall, and we've got the floor, and we've got a 6-meter ladder, something like this, 6 meters long. Of course, this is a right angle. I'm going to call this y and this x. I've drawn it this way to match kind of an xy coordinate plane so that it seems like it's intuitively acceptable. So the first thing we need to do is we need to draw a picture, which we've done. And the second thing we need to do is state the rates. Now, we've been told that the ladder begins to slide away from the base of the wall at a rate of 12 centimeters per second. So I'm going to call that dx dt is 12 centimeters per second. Or we could say 0.12 meters per second. Okay. The reason why this is critical is because we've got meters here, and so we want to make sure that this one here is also in the same units. Okay, and then dy dt is what we're trying to find, and we're trying to find it when the top of the ladder is 3 meters, and so we're trying to find that. Now, when the ladder is 3 meters from the ground at the top, the bottom is also a certain distance. So I'm going to take a moment right now and figure out what the x is when y is 3. So x squared plus y squared equals 6 squared. X squared is going to be plus 3 squared is 36. So x squared is going to be 36 minus 9. X squared is 27. And so x is going to be the root of 27. So I can add that to this set of conditions that when y is 3, x is root 27. Now that's kind of an extra hint or tip. You're going to see why that's important in a second. So we've got a picture. Now we've stated the rates. And now our next job is to figure out what is our equation. And so I would invite you to think of this as the equation that connects the x and the y together in this context. And so I'll simplify that a little bit. Now we've already used this once to figure out the x when y is 3, so this is going to be kind of neat. Now check off that we have our equation, and then the next thing, second last step is to differentiate both sides with respect to time. So that would be 2x dx dt plus 2y dy dt is equal to 0 because the derivative of any constant term is just 0. And then we're going to isolate the one that we're trying to work with, which is the dy dt. So I'm going to subtract 2x dx dt from both sides, and we have 2y dy dt is negative 2x dx dt. Divide both sides by 2y, and dy dt is going to be negative x over y dx dt. So we've differentiated both sides with respect to time, and now our last thing is to solve this. Now we're going to solve dy dt when x is root 27 or when y is 3. So negative root 27 divided by 3 times the derivative of x with respect to time, or the rate at which x is changing, so 0.12. So dy dt when x is root 27 and y is 3 is, if I plug that into my calculator, I get 0.21 meters per second, or 21 centimeters per second. Okay, so I'd like you to give that a try. I've got another one here for you to try, and I have the answer there for you. I'm going to get a negative answer because it's moving. I'm going to get a positive answer because it's moving away from the base. So you're going to get it as 67 centimeters per second. Give that a try and see what you think.